Okay, today we're looking at the second part of carbonyl reaction. So today we're going to look at carboxyl reaction. Last class we saw how alcohol can go through oxidation reaction to either form aldehyde or ketone, depend on if you're looking at a primary alcohol or secondary alcohol. So primary alcohol upon oxidation will give you an aldehyde. A secondary alcohol upon oxidation will give you ketone. Now, today, we're going to look at carboxyl. It's sort of like the continuation of what we saw before. So let's take a look at how we are able to prepare a carboxyl. So let's take a look at example 1. Again, this is another oxidation reaction. What are we oxidizing this time? Well, remember the aldehyde that we saw yesterday? We're going to oxidize the aldehyde. Okay, so we're going to oxidize aldehyde. So remember, whenever you have a square bracket O, or sometimes even round bracket O, okay, what you're going to get here is a carboxylic acid. Okay, of course. Here we go. Now, for this reaction, let's take a look at some example. So what I have here is ethanol. Okay, by oxidizing ethanol, what you're going to get is a carboxylic acid, ethanoic acid. Now, what you can see here is that an extra oxygen was added, which is indeed a legitimate oxidation reaction, because oxidation reaction can have three instances: the addition of oxygen, like we see here, the removal of hydrogen, which we saw yesterday, and of course in chapter 9 we saw the decrease in the number of negative charge. So an oxidation reaction can happen, of course, to aldehyde to give you a carboxylic acid. It's very simple. Now, some of you may be asking, well, is there going to be a catalyst involved here? Okay, or some sort of requirement for this reaction to occur? Well, not really. Okay, there is, but it's specific to a certain type of aldehyde. So I guess for our sake, we're just going to leave this blank, okay, and just pretend that this reaction is spontaneous. Now, what about ketone? Can a ketone go through oxidation and form something else? And the answer, of course, and unfortunately or fortunately, the answer is no. Okay, so let's do another one. I have here propanol. Okay, propanol. Upon oxidation of propanol, what you're going to be doing, of course, is you're going to be adding an oxygen to the carbon, between the carbon and the hydrogen, like right here, to turn this into a carboxylic acid. Now here's a nice question. Here's here's a pathway question that I want you to solve. So I have okay, I have right here CH3, CH2, 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 OH. Okay, I want to go through oxidation, twice. Okay, what would you do? Now, this is actually a very simple question. We know for a fact that this is a primary alcohol. So when a primary alcohol goes through oxidation, you're going to get an aldehyde. So your answer would be this. Okay, when this go through another oxidation, you're going to make a carboxylic acid. Like this. Okay, a pretty easy pathway, and something that I'm pretty sure you guys can put together on your own. Now here's the ultimate question of ultimate question, which I'm going to ask you to think about. Okay, and trust me, this question is going to appear on your next test, whenever that's going to be. I want you to think about this one. This is a good question in a way that it kind of make you think back to everything that we've looked at already. Okay, so here it is. What I have here is an alkyl halide. Okay, chloromethane. I want you to turn chloromethane into a methanoic acid. I want to see how you're going to do that. Okay, so this may be going to be a long pause video. I will eventually, of course, give you the answer right now, but I want you to pause this video right now. I want you to think back of all the reaction that we've looked at since last week, and try to figure out exactly how I'm going to turn an alkyl halide, okay, into a carboxyl. So, let's do it right now. So, pause. All right, I guess you unpaused, and let me just show you the answer. I'm not going to show you the catalyst. I'm sure you guys can figure that one out, but make sure when you're doing this for real, you indicate the catalyst, okay? All right, so this is simple. This is kind of like just one step above the first question I saw that we have earlier, or the one above. So to do this question, you have to think, okay, I have an alkyl halide, and I want to turn that into a carboxyl. Well, from what I know, or what I know so far, that a carboxyl came from an oxidation reaction of an aldehyde, right? An aldehyde came from an oxidation reaction of an alcohol. The question is, can I turn this into an alcohol? Were there a reaction that I learned before that will turn this into an alcohol? And the answer is yes, we actually did. Remember, if you take an alkyl halide and you react it with water, remember what's going to happen? Okay, the OH will actually split apart. The H will take away the Cl. The OH will be bonded to the C. As a result, what you're going to get is HCl plus CH3OH. So you get your methanol. Okay. Now, things are going to be simple now, right? Because if you take this and you oxidize it, you will get methanol. If you oxidize this one more time, you will get the thing I'm asking for, which is methanoic acid. So that is a reaction pathway. Okay, and trust me, I'm going to give you a couple of these reaction pathway to do on your next tests. I will give you some sort of starting material. Okay, could be a alkyl halide, or it could be just a plain old methane. Can you do it if I were to give you a methane? Think about it. Okay, all right, so that is the first reaction of carboxyl, okay, in terms of preparation of carboxyl. So let's take a look at another reaction. So let's call this example 2. This one is extremely important, known as esterification. Okay. In another word, biologists tends to call this dehydration synthesis, because theoretically you're synthesizing, you're putting two things together to become one, or some people just call it condensation because of the creation of water. But the real term for this type of reaction is called esterification, because that's exactly what you're making. Something called an ester. So to make this work, you take a carboxyl, okay, and you react that with an alcohol. Ooh, how can I spell alcohol wrong? Okay, under heat and under the presence of sulfuric acid, you will get an ester plus water. Okay, so that's the general reaction. Esters are quite important, okay, in the chemical industry. And obviously something that we were going to do, I guess, as a lab. We're going to give you a bunch of carboxylic acid and a whole bunch of alcohol, and your job is to mix and match different carboxyl and different alcohol together to form different types of ester. Now the cool part is that ester has a distinct smell. Different carboxyl and different alcohol put together will give you a very distinct scent of ester. And I can tell you right now, one of them smells like banana. It's just a shame that we can't do that, huh? So, let's do this. Let's put these things together. So let's go with the most simplest case. I have the simplest carboxyl, methanoic acid. And I'm going to react that with, let's say, methanol. Notice I drew my methanol this way. Okay? We've seen this before when we were putting together ether, where we're trying to put the OH to face each other. The reason is very simple. Reaction happens here. Therefore, you want the OH to face each other. Orientation, remember how important that was? So again, this is what's going to happen here. One of the participants will donate the OH. The other participant will donate the H. Now, it doesn't matter who donates the OH and who donates the H. That's not a big deal. It could be this and this. Doesn't matter. So let's say is this. Okay? Here's OHH, which is really H2O. Okay? Let me just erase this for a bit, just to show you. Okay? So when H2O is gone, you'll notice that this C is missing a bond, this O is missing a bond. So what do? Exactly. They're gonna bond with each other. So what we're gonna have here is C double bond O, H, O, CH3. Okay? This is an ester. It is an ester because it has an ester configuration of C double bond O, and this C also connected to an OC. So whenever you see this configuration, COOC, COOC, like this, that's an ester. Now, one of the things that I need you to know how to do is name esters. So let's do some ester nomenclature. It's very simple to name ester. You always name the alcohol portion, followed by, of course, YL, followed by a space, followed by the acid portion with the ending OATE. 08. Okay, so that is how you would name this ester right here. So let's try it. So the alcohol portion came from here. This is the alcohol portion, right? That's the alcohol portion, and it was a methanol. So what do we say? We will say this is called methyl, which because it's methanol. Now be careful here. No dash. Okay? No dash. No continuation. I want a space, a clear space, because this space is what they define what ester is about. So, methyl. Now the acid part. The acid part came from here. It's also a 1-carbon carboxylic acid, so it's also a meth. So it'll be methan. This is an ester. I don't want to hear methanoic acid, but a methanoate. So this molecule is called methyl methanoate. Okay? Simplest ester ever. Let's do some more esters, because that's something I want you to get good at. Still feeling bad the fact that we don't get to do this for real in a lab. Would have been great. Everybody's making their smelly solution. Okay, trust me, they all smells good. Okay, I'm not gonna make some stinky stuff like some of your IAs. All right, I have here vinegar. Ooh, that's an ugly looking vinegar. Okay, here's vinegar. I'm gonna react that with propanol. Okay, now how are they gonna react? Well, very simple. Dehydration synthesis, or condensation, or esterification. Of course, this has to be under the presence of some heat, and this has to be in the presence of some acid. So what you're gonna get here is water plus one of these. Okay, now I want you to name it. Okay, just like what we saw earlier, you name the alcohol portion followed by YL space, and then you name the acid portion with the ending OATE. So try that right now and pause. All right, I hope you guys got propyl. Okay, FNO8. Okay, propyl came from, of course, this is propanol. Ethanoate came from ethanoic acid. Okay, let's do one more. Let's do one that involves side groups, so therefore you guys are a little bit more comfortable with that. Let's use a different color. Use blue. Here we go. Yeah, maybe a little bit more. Okay. Yeah, it really doesn't matter. So I want you to do this. I want you to put this together, and I want to see the results like this, and I want you to name it. So again, let's pause. Good. After you finish pausing, let's take it up. Okay, here's water being made, and under the presence of heat and sulfuric acid, you're gonna get CH3, CH with a Cl on top, C double bond O, O, CH2, C with a benzene, CH2, CH3. There you go, that's what I got. Okay, hopefully you got the same thing. Now, the tricky part here is this. If on a test, I would just give you this, and I ask you, okay, guess what? Can you name this? Okay. You have to think, all right, which part is the alcohol portion? Okay, the alcohol portion is always the portion where you look at the O. And you look at the two C's. The C that doesn't have the double bond O is the alcohol portion. The C that has the double bond O must be the acid portion. Hopefully you're able to see that because I will ask you questions about that. Alright, so let's take a look at how we're going to name this. Because there's side group involved, what are you going to do? Now, numbering. Numbering is a pain in the butt. Why? Because there's two sets of numbering here. And the guide is this oxygen. This oxygen will be called the midpoint of your ester molecule. As the midpoint, also known as the starting point, this is where the numbering will start, which means the carbon that is connected to the O is always carbon 1, which means this is carbon 1. Then this is carbon 2, 3, 4. Now, what about this carbon? Like what I said before, the carbon connected to the O is carbon 1. This is also carbon 1. So you have two sequences going on either side of the ester oxygen. Alright, so let's name this. So you have 2-phenyl, 2-methyl, dash, 2-phenyl, dash, butyl. Now, I hope you know why those dashes are important, because if you were to put a space, you would confuse the reader right off the bat. Okay? Either put dash or just connect everything together. Do not put space. We saw what space is for here, right? Space is for the separation between the alcohol portion of the ester and the acid portion of the ester. So don't put in spaces for the sake of putting spaces, because spaces mean something. This is where you put the space. Okay, butyl, what ends, because this is the alcohol portion with 4 carbon. So you put a space here. Now you do the acid portion. So in the acid portion, you would say 2-chloro dash, no space, okay, propanoate. So that's the name. Okay, so that's how you name esters. Now I'm going to give you a worksheet where you're going to be practicing naming esters. I'm sorry, but it is going to be a lot of work. It is something that I really, really want you to know. Okay. All right. Hey, let's do a biology example. You know how much I love biology, right? Here's another example. Hey, look at this guy. Remember him? That's right. Glycerol. Okay. Or you can say 1, 2, 3, I don't know, propyltriol. Let's write that down. 1, 2, 3, propantriol. Because that's what it is under UPAC. Alright, so it's an alcohol. No problem. Okay, propanoic acid. I'm sure you've seen this. Does this look familiar to you? Now, I'm sure the last time you saw something like this, you're not looking at 3-carbon compound. Okay, you're probably looking at a very long compound. You probably have an idea in terms of the name. It's called fatty acids. So when you put fatty acids with glycerol together, what are you going to get? Oh, I made a big biological error. Big biological error. Okay, fatty acids has to be even in terms of the number of carbon, because when your body cleaves these fatty acids for nutrient purposes, for cellular respiration, they cleave every 2. Okay, all right. Now, I don't know about that one because I'm not a biologist, nor do I know anything about biology. But if you were to given this carboxylic acid and this alcohol, Can you do dehydration synthesis? Can you do esterification? Okay, the answer of course is yes. And in this case, this right here can attack this, this, or this. No problem. So let's say it's going to attack this. That's where water is going to come in. Okay. As a result, you will get this. As your finished product. Okay. Now, the thing is, how are you going to name this? Okay, you guys can pause this and give it a try, but I'm just going to quickly name it for you. So you can see that this is your ester oxygen. So therefore this is going to be carbon 1, 2, 3. This is going to be 1, 2, 3, 4. Okay, so what you have right here is a very crazy situation because of the alcohol. Okay, right off the bat, these alcohol will turn into side groups as hydroxyl. You have to use hydroxyl. You're not going to say propol, right? That makes no sense. So therefore they become hydroxyl. Because in terms of priority chart, ester do play a role. In fact, ester is just right below carboxylic acid, but you don't need to know that. Okay, so in this case, when you're trying to name this, you will say 2,3-dihydroxyl. Okay, dash propyl. Okay, so notice you can't really say propantriol or propandiol or something like that. You have to turn those alcohol into an hydroxyl. Okay, so this is what you're looking at here is 2,3-dihydroxyl. Of course, propyl. Then you have your space. Okay, and you would name the acid portion right here with an O8 ending, and that will be butanoate. Okay, now in biology they have a very special name for this. It's called monoglyceride. Okay, hey, monoglyceride. Can I have diglyceride and triglyceride? Definitely. All you need is, I don't know, another fatty acids. Okay. To make diglyceride. Maybe 3 fatty acids to make triglyceride. So if you're given, of course, this situation, obviously you'll have 3 esterification reaction where you'll form this big molecule, and that will be, of course, your triglyceride. Now, in terms of naming that, it's extremely complicated, and most likely it's not going to be an IUPAC sequential name. They're going to try to give this a biological name by naming it through lipids nomenclature. Okay. I hope you guys know how that works. It's actually very simple in terms of lipids nomenclature. All you have to do is name these fatty acids. If they're fatty acids, every fatty acid has its own name, and you would name them alphabetically, and that's it. Okay, it's pretty simple to name these triglycerides or diglyceride. In terms of this, we can still name it IUPACly, but of course it's a monoglyceride. Anyways, that's ester. Now, the third one that we're going to talk about, of course, is really just the reverse of ester. Okay, so example 3, we have hydrolysis. Okay, In this case, we have some sort of ester. Okay, so here's an ester. This guy is called ethyl methanoate. Okay, if you would put that in water, hydrolysis will occur. Now don't worry about the catalyst here. There is a catalyst, but again, this is going to be one of those specific one. So what happened is very simple. Let me just kind of draw the water instead. Okay. The water will break into OH and H. Okay. The H portion will probably bond with the O. The OH portion will probably bond with the C. Like that. So as a result, you get the reverse of esterification, giving you this, and of course, this. Okay, so hydrolysis is the reverse of esterification. And it makes perfect sense in terms of the wording. Hydro means water. That's water. Lysis means to break apart. So that's exactly what you did, right? You broke apart H2O. H will come over here to hook up with the O. OH will come over here and hook up with the C. Okay? So what you're going to get here, of course, is ethanoic acid and ethanol. Well, I think I made a mistake here. This is not methanoate. What am I talking about? It's ethanoate. Shame on me. Again. Okay, so that's carboxyl in terms of this reaction. Esterification being, of course, one of the most important thing in the organic chemistry or even biology. And hopefully you guys understood all of this. And hey, work on that worksheet tomorrow. Okay? All right. See you later. Bye.